So, so welcome everybody to this Ask Me Anything session with Byron Cook. So Byron doesn't need much of an introduction, but let me nevertheless say a few words about him. So Byron is a professor at UCL in London, but also a senior principal applied scientist at Amazon Web Services based in New York. And he's interested in formal methods in a broad sense. He's worked on a number of projects with tremendous impact, such as Terminator, the Slayer tool, which was a predecessor or at least inspired the Facebook Infer tool. He worked on the static driver verifier SLAM at Microsoft and many others. So his research was also awarded various prizes. So one of them, a very important one, is the Roger Needham Award. And Byron is also a fellow of the Royal Academy of Engineering. So I'm super happy that I'm able to welcome Byron. So hi, Byron.
Hi, thanks for having me.
It's going to be fun to talk to you about your work for a while. So for the audience, we have a Slack channel. So if you have questions that you would like to ask Byron, please just put them in the Slack channel, and I will try to make sure that they find their way into the AMA session. Please also include your name and your affiliation when you post those questions. So let me start, Byron, with a question from my side. So, I mean, for decades, really, researchers in formal methods have tried to convince the industry that it would be a good idea to apply formal methods on a larger scale and to increase software correctness and security that way. And not that much, honestly, has happened. And then like 6 years ago, you joined Amazon, and within a couple of years, you turned Amazon into a powerhouse of verification and into one of the biggest players in that field. So what did you do differently? How did you succeed there?
I mean, the time was right? So, I mean, I'm really lucky to have been in the right place at the right time on 2 or 3 occasions. So the one that was the most remarkable is when I was a PhD student, and I did an internship at Intel in the 90s, right after the floating point division bug, so FDiv bug. So basically, Intel had to replace a bunch of hardware because floating point division was wrong in some cases, and that caused a lot of pain for customers. Basically, the answers were wrong. Rockets could fall out of the sky potentially, and so what they did is they invested pretty heavily in formal methods right next to where in the Pacific Northwest where I live. So I did an internship there and really saw some of the greats out of that era working, applying formal methods, and seeing that the business really needed it. So and then I'd say the static driver verifier was another case where I was sort of at the right place at the right time, where the problem, they needed formal methods, and that's really the situation now at Amazon Web Services, is that we operate at such scale, and so many crucial workloads for the world are running on top of AWS networks, virtualization, using our crypto, using our storage infrastructure, et cetera, that the customers are really wanting it. And so that's one thing I've seen, and I'll be happy to tell you some stories about how Amazon helped accelerate that. But basically, the pull from customers for Amazon was pretty dramatic. So it was kind of being in the right place at the right time, but then being ready, when customers were asking for it. So one thing I saw when I joined Amazon, within weeks, the sales people had me visiting some crucial customers. So I'm talking to the chief information security officers of major banks, and right away they were like, this stuff would be super important to us. And then they've supported, a lot of the customers have supported the work as we've grown it and communicated that to the leadership of Amazon. So the Amazon leadership has pretty early on heard that this was important to customers, and so then they've invested in it. And so from there, it's actually been relatively easy. It's just joining up the cultural differences of the formal methods community and the Amazon culture. They have some different ways of seeing the world. So bridging that has been sort of the main thing I did early on.
Interesting. So now the way you describe it, you say basically the motivation comes from the customer side, and then management saw the need. So how hard was it then to convince the engineers that actually need to do the technical work to use formal methods?
So some very hard, and some we still haven't, and some super easy. And so one thing, learning from the playbook back in the strategic CAD labs at Intel days, I saw is the guy who started that effort, he started 4 or 5 projects. And so that's what I decided to do. It's like, let's start 4 or 5. I'll hire some of my friends, right? So I hired Ernie Cohen, Sordo Tezran, Michael Tauschnig, some different sort of folks early on. And I said, let's give this a shot. And I sort of rolled the die, right? And some things didn't go well because the technology wasn't working. Some things didn't go well because the people we were trying to work with didn't find it groovy. But other cases, we hit Peter. And so there's a couple, like one example that was early on was a big success was, so I went and visited Seattle, where at the time, I mean, Amazon is now, AWS is now so much more distributed than it was when I first joined, but there's a lot of critical mass in Seattle at the time. So I went to Seattle and met with a bunch of people. And one person I met with Cole McCarthy. So he was in the EC2 networking team, and he was writing our own implementation of TLS. So it's called S2M. It's now open source. You can find it. And he basically said to me, like, my 6th week at Amazon, I'll rewrite every line of code if you can help me prove it correct. He's like, if you want to put in a bunch of annotations, you want to, like, whatever it is you want to do, whatever tool, if you can help me prove that it doesn't corrupt memory or certain key properties, I'm in. And he weekly attended meetings. We got folks involved. And so basically, in the early days when people were joining Amazon, I was like, join that project first, right? Because you'll sort of feel some love from developers. And then what's happened over time is that his enthusiasm has been infectious. And so other people that were a little more hesitant would talk to Colm, and then they'd be like, oh, okay, now I get it. And we had Colm is just one of 7 or 8 examples where people pretty early on were like, sure, I mean, if the tools will work, that's fine. And even if the tools don't work, they don't need to work right away, but if you can provide a bit of value, we'll use it. And then as we've succeeded, then they've spread the word. And then other people who are a little more hesitant were like, sure, we'll try it. So, I mean, nowadays, for example, the crypto team, so the encryption SDK team in the crypto organization has 8 developers all writing Daphne code and proving properties in Daphne on production code, basically because they heard, the development manager heard the wins from Colm and others on crypto related projects. So it's sort of spread by word.
Fantastic. So quite a few people on the chat are interested in learning more about the kinds of formal methods that you're using. So if you look at the space, then you can roughly divide them up into, say, foundational verifiers based on tools like Coq and Isabelle, like CompCert and CakeML and so on, or SMT-based tools like you just mentioned, Daphne, or bug finding tools or bounded verifiers like CBMC and Facebook Infer would also be in that category, of course.
Yeah.
So how do you see that space? I mean, are you using everything, or do you have particular problems for which you choose particular tools?
Yeah, so in the early days we used, I tried to be pretty select. So I had this sort of chicken and egg problem. So I mean, I was joining from a pure research lab, I was joining an organization where there was no research in this space. So in the early days, I really had to deliver quickly. And so I used tools that were working, that I figured would pretty much work out of the box. And I tried to find really high value problems where within 6 months, people would be taking their breath in and being like, wow, that's amazing. So we applied Z3 and CBC4 to reasoning about resource policies, which is a big topic for customers. We were using Souffle and later Monosat to reasoning about networks. We were using CBMC and Galois SAW tool to virtualization and crypto, very low level code. And we're using VCC and Coq and some other tools to reasoning about protocols. And so those tools are chosen because they were pretty much working out of the box. And I figured that within 3 to 6 months, people will be like, wow, that's cool. And then from there, we would now have the flywheel going, the chicken and egg problem would be solved a little bit, and we'd begin more and more and more to invest in the underlying tools. And then the increase in power of those underlying tools would then allow us to do more, and we would just, everybody would win-win situation. So that's how we started, and then things have really grown from there. So actually, on Friday, there's a session that Amazon is hosting, and I think someone's going to post it in the Slack channel, where we're having, I think, 6 or 7 of the different leaders of the different teams that are applying formal methods in Amazon to all come and join, and anyone here can join that. You can write to me at byron@amazon.com. If you can't figure it out, I'll get you an invite. But the point is that each of those business groups has their own strategy, their own dynamics, their own cost structure. The customers are asking for certain things, and so those choices are really dependent. So currently, from memory, the sort of state of the art is we're using Coq quite a bit to reason about security protocols. So the sort of crypto protocols about how distributed secrets are distributed. We're using Ankush Desai, the P tool, for example, to model check some protocols, and then we're using VCC to try and deductively prove models of those protocols. We're using some bounded model checking, and then also some induction techniques to try and reason about lower level programs. We're continuing to use the SMT and SAT quite a bit, and we're using program analysis techniques, for example, like SIT, and we're interested in going all directions. And now, because the different groups have been so successful, they have their internships, their teams, their budgets, and so we're with each of those teams at various levels of interaction, helping them figure out where to go. But they're investing in different aspects of all of those things. So yeah, I guess the short answer is we will use anything that works.
And could you also elaborate a bit on how you're using these tools? I mean, some of the Lighthouse projects, say SEL4 Verified and others, have really made the point that the engineering, the design, and implementation, verification need to go hand in hand. You cannot just throw the code over the wall. Is that also what you are doing?
More and more, yeah. So yeah, in the early days, that was, with the exception of Colm, basically the only way to succeed was to go, we did a very important proof of the underlying protocol of KMS. That's a very important service in AWS. It's called the Key Management Store, KMS. And it's a distributed system that keeps your crypto keys. So you really want that thing to be secure. And so we went and built, reasoned about a model of that system. There's a paper published Oakland, I think, on that. But that was done after the system had been developed. But what's happened over time is more and more and more, like Sardar Tasaran and Ernie Cohen, Rajiv Joshi, et cetera, are working more and more with the storage team to reason about the protocols and systems that are being developed today, as we speak, with systems folks. For example, Andy Warfield, that will show up, a year from now, in the underlying storage infrastructure. And so more and more we're actually involved in the design of the systems while doing the proofs at the same time. And that's like with Rooston's work with the crypto team, that's happening too, right? So they're actually doing proofs in Daphne of the code as they're writing it, and then compiling to Go, .NET, JavaScript, Node.js, et cetera, et cetera, et cetera. So that's really been a trend that we're seeing, is that more and more we're helping develop the code while proving it, and it's just a world of difference.
Great, fantastic. So if you just look into the future, so do we have the tools now that we need to do verification in industry, or do you see still major bottlenecks, major challenges that the research community maybe should address to make those tools even more applicable?
Oh yeah, we're only really, as a community, basically from, I don't know, like Zohar Mana's time or Turing's time until today, we were facing this massive chicken and egg problem, right? The IT industry was moving way faster than we were. and developing all these features. So cloud, iPhone, you name it, all of these like things that we use, were moving so much faster than the formal methods tools could move, that we were becoming increasingly irrelevant, even though we were very proud of ourselves when we read our Popple papers or CAV papers or whatever. And by the way, this is from a purely formal methods perspective. There are some aspects where for example, in PLDI with more static typing, for example, have had more impact. But generally speaking, the sort of your style and my style of formal methods has essentially been irrelevant, and we've been kind of in these monasteries, keeping the art alive, keeping the one true way alive, while the rest of the world went a different way. And now, what I'm seeing in Amazon and in some other companies, some of whom are very secretive about what they're doing, but they are hiring like crazy, and we're competing with those companies for talent, is that the two areas are merging back together because devices are networked and security is so important, that they're like, wow, okay, so actually these things have a lot to add. And so they're beginning to use them. And what's really neat about these companies, and Amazon being one of them, is they're actually really comfortable with tools kind of only partially working. So they're pretty comfortable with like, well, if you can move the needle a little bit, then we'll understand the value and we'll pour more investment into it. And so that's what we're experiencing now. So just as one example, but there are many, basically, and I know I'll anger a few people by saying this, but basically, we haven't used distributed computation at all in our formal methods tools, right? Yes, there are some provers that have portfolio approaches and they try in a data center with 20 different settings on the stat solver or whatever, but we're not really deeply used. We don't have like an eventually consistent search for an inductive invariant tools that really use that in a powerful way. So you can imagine, for example, Ken McMillan's impact tool, running that across thousands of machines and then having some eventual consistency on the graph that he's building, and that would massively improve scale. And there's this huge set of computers that you can run at very low cost. That's just one example. So we have the concurrency, dynamically typed systems like Python, reasoning about distributed systems themselves. Like there's just like a world of open research problems, and I really think it's like an amazing time to be joining the field, because now there is interest, money. You know, I think last year we hired 30 PhD student interns into the program, and I think this year we're at 50. So like the growth is there. So there's just a lot of opportunity and a lot of good problems to work on. And yeah, and I think it was Strachey who said that the division between theory and practice is injurious to our field, that really you need the two to be working together. And so now we're kind of in that magic moment where people who have theoretical formal verification backgrounds and then the people who have the real problems are working together. And so there's real magic happening right now. So yeah, so it was a very long answer to your short question. So.
No, that's great. Thank you. So you just mentioned Python, and of course, Python is used a lot for scripting. And I got a question from Marat Akin along these lines. He said, lately, more and more features are moved to configuration out of the code and into configuration files. And what role has verification to play there?
Yeah. So by the way, there's good work on Python itself. I want to use more of that. We haven't been doing a lot of that work. I think that's one of the areas where I think there's a lot of scope. But to the question of configurations, that's really been one of our money makers, right? So in the cloud, so when you develop code in the cloud, and increasingly everyone does. It's actually, when I joined, it was really shocking to realize how much of the world's infrastructure runs in the cloud. Really what they're doing is they're moving, like your queues are now, there's an AWS service called the SQS, it's queues, and you have policies that's effectively written in first order logic to describe who can access what, when, where, and there's roles, and there's role assumption, and blah, blah, blah. So there's basically these configurations that decide what can have access to these resources. And the same for all the virtual networking infrastructure. So basically all of the concepts for networking, they've moved virtualized into the cloud. That's all now configuration as code. And one of the real challenges when I began going around and talking to customers in in pharmaceutical and banking and government and so on, was that they were having problems getting the configurations right. Misconfigured resource policies were causing problems for customers. And so we began applying SMT. And the cool thing is that in many cases the problems are actually decidable. They're still intractable, but they're decidable. And so now it's like we're so set to solve those problems. So one of the tools is called Zelkova, which has just been this fantastic tool. So Zelkova is used there's AWS config rules. There's S3 block public access. So S3 is one of the big storage services from AWS. It uses Zelkova very frequently. And now there's a service that people in the formal methods crowd inside of AWS built and own called IAM Access Analyzer, which is reasoning about, again, the resources, the configurations. And the similar thing is true for the virtual networking infrastructure. So John Backus, for example, he comes originally from Rockwell, and Sam Bayless, for example, are working on this tool called Tyros. Sean McLaughlin was one of the early folks on that, Paul Subotic. And that's in a service called Amazon Inspector. And that helps customers reason about the reachability within their virtual networks. And again, it's sort of a configuration question. They don't have loops per se. The problems are decidable, but they're very intractable, and customers can get into a lot of.
So what are the research problems that excite you for yourself, not for like a team at Amazon?
Yeah, so actually, I mean, I've gone through a bit of I've kind of hit this inflection point. So I was in a Blue Skies research labs situation, and then I joined this. I reported to the Chief Information Security Officer of AWS, and he's like, I have no idea what you do, but give it a shot. And then they incrementally doubled down. Every year we doubled in size, basically. And I kind of hit this point where it's like, whoa, like 2 years ago, I was able to read papers and think and make scientific contributions to projects. But at the rate of growth right now, 2 years from now, I'm just only going to be doing budgets. And so I was like, I've got to get out of this game. So, but the nice thing is that AWS is verification. What was that?
Or get into Excel verification. If you only do this, then that's another interesting problem.
Referring to Simon PJ's thing. So the nice thing is with the success, I was able to hire or have AWS hire some folks who had been at Amazon for a long time and had delivered these kinds of services, but also were very interested in the formal methods, had been tracking the work, for example, of Ranjit Jala's liquid types or John Harrison's Hull Light work, etc. And so I've been able to get more back into the science. So I'm actually, much of my time now is spent coding. I've actually been coding in Python, weirdly, and then writing. So I like my monitor right now has a VI open with a bunch of tech. I'm actually working on a Popl draft, and so that's been really thrilling for me for the past 6 months. I've really gotten back in the game. So the things I'm working on right now is I'm very excited about distributed proof, about taking a single question and then taking 10,000 machines and getting hopefully linear speedups. And so Marijn Hula, who's the parallel SAT person, has joined our organization as a scholar. So he's a professor at CMU, but he's also part-time in our team. And so I've been talking to him and working with him and tracking that work. And I'm really interested in distributing SAT, distributing SMT, distributing symbolic model checking. So that's one thing I'm really excited about. And the other thing I'm excited about, I've been wanting to get my hands much dirtier with regards to AWS. So I've been trying to really deeply understand all of the aspects of So in AWS, there's something called IAM, Identity and Access Management. It's one of the sub-services. It's where you have users, roles, role assumption, tags, you have session policies, resource policies, they have all these concepts, boundary policies, service control policies, and they all interact for different scenarios for customers, and to really understand in a deep way the semantics of that system. And so I have a model in both tech and then Python for testing. So I have so basically a model-based testing tool to make sure that my my model is correct, and then I'm working on a tool that reasons about role assumption. So that's a couple of things I'm doing. But I'm also, as in my role now, so one thing is as the different identity, crypto, the program analysis, the security team, for example, the AppSec team, the application security team, Prime Air, Prime Video, like all of these teams have been investing in model checking, program analysis, formal verification, you name it. I've been involved in helping helping the different leaders understand the value of that, and helping make sure the right levels of investment are made, and also helping people get plugged in as they want to join Amazon, trying to find the right sub team for them to join. So that's something I've been doing.
So you spent most of your career in industrial research, right? At Microsoft Research first, and now at Amazon, but you've also had a leg in academia as well. So how do you compare the two? Or, I mean, why do you spend most of the time in industry? Is it like the access to problems? Is it the resources? Is it the potential impact that you have? Or, I mean, why did you make that career choice?
First, a couple of quotes. So I won't get the quote quite right, but F. Scott Fitzgerald said that the test of true intelligence is someone who can keep two opposing viewpoints in mind at the same time to make progress. And then there's the Strachey quote, which is the division between theory and practice in computing is injurious, that theoreticians don't know what to work on and practitioners don't know what they're doing. And that you really need to have both of those things in mind at the same time. And by complete luck, I learned that kind of the hard way. So the hard way was that I was a very, very pure researcher doing a PhD in Haskell type system kinds of things, working on parametricity theory. And the .com crash happened, and I had 2 children, and I needed a job, and I needed it right now. And so I went to FMCAD conference and begged every company to hire me now. I couldn't move. I couldn't start right away, but I needed cash. I needed a signing bonus. And otherwise it was going to be doom, like homeless situation. And this company Prover hired me. And so that's Gunnar Stallmark's company. At the time, this is pre-Schaff, but had a very powerful SAT solver. And they hired me as a pre-sales engineer. And so I was going to Intel and various startups at the time that were doing work in symbolic model checking of hardware, and helping them use this Stallmark's algorithm based or symbolic model checking tools. And all of a sudden I learned all these problems that I didn't know about in my sort of ivory tower situation. And then I joined the Microsoft, and I actually, the amazing thing was, by happenstance, I lived near a friend of a friend who turned out he worked at Microsoft too, and he and I commuted together, and he was in the storage team, so he owned like the SCSI device driver, and in the grueling Seattle traffic that we would spend all of our time together. We spent like 2 hours a day together. I was asking him questions, and he kept using the word eventually when I was asking him about things that you would want to prove with the Windows kernel or device drivers. And I was like, oh, wait, I thought from talking to all my friends in the formal methods world that termination wasn't interesting. That's what we kind of told ourselves, right? It was like termination, it's safety that people worry about. When I was talking to people who actually were boots on the ground, they were saying the opposite. They kept using the word eventually. And I realized that liveness is a really important problem. So that's, again, one of those questions where, like, if I had been super, super applied and only applied, I wouldn't have done formal methods at all. I would have just been like, oh, what you need is help getting your driver working correctly. But I didn't do that. But on the other hand, I wasn't like, I'm a purist. You know, the problem is undecidable. We should look for decidable problems to work on, right? The fact that I was sort of in both mindsets at the same time, and in that sort of hot spot between applied and theoretical, was why I started doing the Terminator, which then just exploded. And I had all these papers. For a while, everything I turned to gold, right? I could not get a paper into Pop or PLDI. And that was because I'd sort of like hit pay dirt because of that perspective. So that's really what I was looking for when I joined Amazon, was to refresh that experience, was to get myself out of my comfort zone and then create the world I wanted to be in, right? So and so now we have, I mean, so many good people, you know, John Harrison, Daniel Kronig has joined, Rustam Lieno, you know, Neha Rungta, all these great people with very strong formal methods backgrounds, and a lot of support from the development teams, the service teams, and so there's a great mixture of that world. But for the first year, it was pretty applied, and that was on purpose. So that helped me. That I find that I do better research that way. So sorry, that's again, man, I'm great at these long answers.
Well, that's great. That makes my job easy. Thanks a lot.
Okay.
So I got a question here from Ellie, actually, who wants to know a bit more about your past research. So he asks, predicate abstraction was one of the big breakthroughs for making software model checking mainstream, largely thanks to the SLAM project in which you were involved. What do you think of predicate abstraction now?
It's a tool. It's one of those things where it's like, once you see, when I saw Bebop, which was the underlying Boolean program model checker that SLAM uses. When I saw that run, I was like, oh, wow, okay, that's something pretty amazing, right? And it inspired me, and it inspired a lot of other people. And so, for example, just to like take this thought to its extreme, Ken McMillan, for example, with his impact paper, I think it's CAV 06, it's in something like in, he has a number of papers with interpolation in the title, but there's one where he basically unfolds a program and interpolates along the way and finds an inductive invariant. That thing completely throws away predicate abstraction altogether. But the underlying tool is actually way more reliable. Like, it doesn't get stuck trying to find predicates. You don't spend all this time. Like, it's just so much better for the kinds of problems that we were applying predicate abstraction to. But on the other hand, predicate abstraction is a tool, and it works really well in some cases. So it's so I think is it Graf and Saidi who first invented predicate abstraction and sort of in the terms that we know it. That's a very powerful paper. But like, now there's so many other approaches that can be mixed together in different ways, and you can make really powerful tools. So it's sort of like when you hear recently, because of the pandemic, I've been listening to old albums. So I listened to like the entirety of the band The Byrds, and a lot of their songs suck, but they were like so ahead of their time that like you've got to respect that jangly guitar sound, even though now it kind of sounds a little tired. And so I think predicate abstraction is kind of like Stephen Stills. There you
go. For the next pandemic, you'll pull out the papers and read them again and enjoy them. Good. So I also have a more personal question here. I mean, it seems that you're having kind of three careers at once, and you have a family and an active life. So how do you maintain your mental health? How do you ensure that you somehow have some kind of balance in your life?
Yeah, I've got a lot going on. Like I'm a professor at UCL, have the Amazon job. I actually, until COVID, I was dividing my time between London, New York, and Seattle. So that's a lot to manage. And I have kids. The kids are adults now. So I have one born in 1990 and one born in 1996, whatever those ages turn out to be, if you do the arithmetic. So work-life balance is non-existent. So I look for work-life harmony. So I basically, I saw a talk recently by Ranjit Jalla, like a mentoring workshop at CAV in New York, where he's like, if I'm not having a good time, I close the computer and walk away. And I really try and follow that kind of idea too. So there will be days where I'm just like, actually yesterday I was having a pretty bad day and I'm just like, screw it. And yeah, I just like, you know, I wrote to a couple people, I'm like, I can't meet, sorry. Like, and I just like went and did other things. But today I'm feeling better. But then last night I was really inspired. So I actually worked till 3:30 a.m. last night. So I basically have got myself in the position where I have freedom to work or not work when I want to. And this idea of oh, you should only work certain hours or something, that doesn't really work for me. I have sort of weird sleep habits. And the thing that I think that I could imagine you feel the same is that, like, you know, like in a sense you and I are competitors, but we're also collaborators. So we're trying to make each other better, but sometimes my paper doesn't get in because your paper did get in. And there are people worldwide working on these things and they're getting better and better and better. And so I've just chosen not to worry about it or stress out about it. So I try and collaborate when it's fun. When the collaboration isn't going well, I drop it. I try and make everyone's life better. So like if people are needing help or need ideas or blah, 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 I try and help out. And I try not to stress about the larger global thing. And for the most part, that's worked out for me. But there's a lot of opportunities I've not had because I didn't have the time. You know, like I didn't have time to write the paper. I didn't apply for the grant. And ultimately, it's kind of worked out okay. I mean, I have a pretty good career, but it could have been better. But you know, I've had a good time. So
yeah, that's what matters ultimately.
Yeah.
So Byron, thanks so much for all your kind of open and frank answers. So let me close the session with another question. So if you had a wish towards the community, what would you wish for?
Whoa.
Being it technical or social, whatever you think is needed most.
I would love for our community to gracefully make a social transition. So I think that our community has been a little snobby in the past because we were purely from this research. We have this sort of monastic view of the world, and so we were obsessed about the brand name of the university we were at, or you know, like where your PhD came from, or what awards you got, and I think that our world's gonna be way better if we sort of put all that aside and just work with people who are doing cool stuff. And people who seem to be moving forward, work with them, right? And not worry so much about, did they go to the right university? Did they have the prestigious job? And so on, and spread the resources around, create more diversity, more opportunity for voices from people from different places. And I'm seeing that definitely at Amazon. I'm seeing that, and I'm seeing in the community, but I'd love to see more of that. So more, yes, I guess more diversity, and more opportunity for people at different institutions to do this kind of work, and the people at the, you know, like the top schools to help out the folks not at the top schools, get the grants, get the good PhD students, you know, do good work.
Sounds great. So thanks so much. It was a really fun and inspiring conversation. So thanks a lot for taking the time to talk to me today. I'm sure our listeners enjoyed it as well. And
actually, can I make one plug? So on Friday, Amazon is hosting with, I think, 7 or 8 leaders of these different teams. So you can write to me at byron@amazon.com, or I think someone in the Slack channel has posted a pointer to it. So you can RSVP for that session, and there'll be a bunch of folks on those teams. We can talk more about this kind of stuff if you want to join.
Sounds great. So thanks again, and enjoy your day.
Thank you. Bye.
Bye-bye.